But within these two sets, is there anything that they share in common? So if we took both candidates' promises to be a set, A could be the label for Amy's campaign promise, D for Darian's campaign promise. And we saw before that both A and D have a common element, spend less money. So in their Venn diagram, if this is our universal set, here are Amy's campaign promises, here are Darian's. Visualize, where would the campaign promise of spend less money reside? It would belong to their intersection. So the only campaign promise that they share in common is spend less money. And then if we were to label the other campaign promises, well, Amy also promised the traffic enforcement in the suburban areas, so we might call that T and S. Where we locate these two doesn't matter so long as they are within the section of Amy's campaign promises that are not shared with Darian's. And then Darian's remaining campaign promises are the crooked politicians P, increased service to the city, so P and C. And where I place these doesn't matter spatially so long as they're within the section of Darian's campaign promises that are not shared by Amy. So this is how we would visualize and label intersections within Venn diagrams. Now the mathematical notation that we use to show intersections is this upside down U. So we would read this left to right as the set A intersected with the set D. The only thing they share in their intersection is the campaign promise M. So the intersection of sets A and B, written A intersect B, is the set of elements common to both A and B. So A intersect B is all the elements that are common or shared by set A and set B. And A intersect B is also a set, particularly it's a subset of A and it's a subset of B, and more generally it's a subset of the universal set. So let's draw our basic Venn diagram for the intersection of A and B. To begin, we draw our universal set. And within our universal set, we have set A, we have set B, we make sure we show there's an overlap. And often we'll be asked to maybe shade the Venn diagram to show where is A intersection B. So if I was to shade their intersection, it's what elements are part of A, at the same time part of B, only this overlapping section. This would be A intersect B. So we've looked at the intersection in terms of where would it be located in our Venn diagram. Now let's find the intersection if we're given the two sets listed element-wise. So reading this left to right, again, the braces tell me that I'm looking at a set. So I'd begin by saying the set whose elements are 3, 4, 5, 6, and 7, close brace, so that tells me the set's over, intersected with the set 4, 6, 8, and 10. Close the set. Because of the symbol of intersect, the question that I need to ask myself is, what elements do they share in common? So let's look. 3 is in this set, and you quickly look left to right. Is it in this set? No, so it's not in the intersection. And just keep moving left to right. 4 is in this set? Look, it's also in this set. So I'm going to indicate that they're shared, maybe just by doing a dot over the top so that I can write it all out at the end. Continue moving to the right. 5 is in this set. Look, it's not in the other set, so we move forward. 6 is in this set. As I look, I see it's also in this set, so I mark those to include in the intersection. 7 is in this set. It's not in this set. And at this point, if you finish going element-wise through the first set and you found all the things they have in common, I don't even have to check these elements because if they had been shared in common, they would have already been highlighted as I went through the first set. Now, if you want to, just to be sure, you can, but notice 8 is in this set, it's not in this one. 10 is in this set, it's not in this one. So the only elements that are shared by both sets are 4 and 6. That is their intersection. Now, before we go to these two, consider this question. What is the intersection of the set 1, 3, 4, 7, 11 intersected with the set 1, 7, 11, and 12? I encourage you to pause the video now and find what lies in their intersection. Unpause to check your work. Element-wise, starting in the first set, 1 is in this set. It's also here, so I mark it to be included in the intersection. Continue, 3 is here, not here. 4 is here, not here. 7 is here, but also in the second set, so we include that in the intersection. 11 is here, also in the second set, so we include it. Once we've reached the end of the first set, we know we don't have to check anything remaining in the second set because if it was in the first, it would have already been collected. So the elements that are in the intersection are 1, 7, and 11. Now let's look at this next example. Take a moment to think, how would you read this left to right? Remember, when you see the squiggle, you know that indicates the set. So the set, whose elements are 5, 9, 11, close the set, intersected with the empty set. And one thing that you really want to make sure you're doing as you're learning this new material is you want to, based on seeing this, be able to verbally say what this represents intersect. Based on seeing this, you should say empty set. And the only way to do that is to memorize the meaning behind these symbols. So as I've encouraged you before, definitely make note cards or find some way to associate the meaning with these particular notations. Okay, now to be in the intersection, it has to be in both groups. But let's ask ourselves the question, is there anything in the empty set? So are there any elements in the empty set? The answer to that is no. By definition, the empty set has no elements. So if the empty set doesn't have any elements, can it even have anything in common with anything else? No, because the first set has elements 5, 9, and 11. What does this have in common with the empty set? Nothing. What's the set that represents nothing? That's the empty set. So their intersection is empty. Take a moment to attempt this next one on your own. Pause the video, unpause to check your work. Nine is in this set, it's not in this one. 14 is in this set, it's not in this. Same for 25, same for 30. At this point, I know if there's nothing in common from the first set, there'll be nothing in common for the second set, because I've kind of already checked that. So whenever there's nothing in common, the intersection is empty. And we have a particular word for when two sets have nothing in common. If the intersection of two sets is empty, then we say the two sets are disjoint. And then visually, as a Venn diagram, if the two sets were disjoint, you would visualize that by their two circles completely separate. There's nothing in common between them. So if you know that two sets have nothing in common, you should draw their Venn diagrams with the two circles representing the subsets completely distinct. The next set operation that we're going to look at is the union of sets. So let's go back to our earlier example of the two political candidates and their campaign promises. We already talked about what campaign promise do they share. But suppose a voter wanted to consider all the promises made by any candidate that we were talking about between those two. To do this, the voter would study all the promises made by either candidate, and that would form this set. This is the union of the two campaign promises. All the promises that Amy made and all the promises that Darian made. And we denote the union by the symbol U. So our definition that we can come back to if needed is the union of sets A and B, written A union B. As you read this, you should say that in your head, A union B, is the set of all elements that are in either A or B. And the way I think about this is they can either be in A, they can be in B, or they could be in both. So they could be in that section that's just A, they could be in that section that's just B, or they could be in the section that's both A and B. And A union B is a set itself. It's a subset of the universal set. Now, in order to figure out what would be the union of two sets, there's actually a very simple way to do that. Because it's everything in the first set and everything in the second set, all we have to do is write down every element of the first set and then also write down every element of the second set that's not already listed. And the reason we say not already listed is we just don't want to write repeats. If we do have the repeats, it's not wrong because we know repetition in sets does not matter. But just for simplicity, we try to exclude the repetitions if possible. So if I'm asked to find this, think about how you'd read that left to right. Braces tell me I should say the set, whose elements are 5, 9, and 11, union with the empty set. Well, I know how to find unions. I write down every element of the first set, and then I follow by writing every element of the second set that has not already been listed. So I write down 5, 9, and 11 because that's my first set. And then I think, are there any elements in this set that have not already been listed? Now in this particular example, remember the empty set has no elements, so it has nothing to contribute. So at this point, I close the set braces. Now, if you would, attempt the next two problems on your own. Remember, you can reread how to go through the process highlighted in purple above. Pause the video, and then unpause to check your work. So here I would read this as the set that involves 3, 4, 5, 6, and 7. Union, the set that involves 4, 6, 8, and 10. I know I begin writing out the union by just listing everything from the first set, so 3, 4, 5, 6, 7. And then I'm going to add everything from the second set I haven't already included. So 4 actually has already been included, so that's good. 6 also has already been included, so that's good. 8 has not, it's new, so I'm going to add 8, as is 10, also new. So this is the union. For our next example, I write down everything in the first set, and then I add anything that has not already been included in the second set. So 10 wasn't, so I include 10. 17 wasn't, I include 17. 19 wasn't, neither was 38. Or 52, and then I close the brackets. Now, if you attempted these problems on your own, look at your work at this moment and ask yourself, did I include these brackets? If not, make a mental note to do so in the future. These are important because they denote the set. They're saying the set is everything within the brackets. So be sure to begin the set with the brackets and end the set with the brackets. So far we have learned about what is a complement of a set, what is the intersection of two sets, what is the union of two sets. So let's combine all those together and start talking about finding intersections and unions of complements. Now, as a quick reminder of what is the complement, whenever you hear the complement of A, you want to be able to say this definition because the only way you can work these problems is if you know what you're being asked to find. So if you hear the word A intersect B, you should think all the things that are in A that are also in B. If you hear A union B, you should think all the things that are in A or in B or in both. And if you should see the word A complement, you should think everything in the universal set that does not belong to A. And that's what we're reminded of here. A complement is formed by taking every element of the universal set that's not in set A. So in our next example, our universal set is the set whose elements are 1, 2, 3, 4, 5, 6, 9. Closed set. A is the subset defined to be made up of the elements 1, 2, 3, 4. B is the subset made up of 2, 4, 6. C is a subset made up of 1, 3, 6, 9. And we are asked to list out what elements belong to this. Now, we can't answer the question if we can't describe the question. So if you would take a moment and in your mind or out loud, how would you say this in words? Read left to right. So this is A complement intersect B. So it's everything that is in A complement and also in B. Now, A complement, ask yourself, of all the things that have been listed and given to us as information, was A complement given? The answer is no. A was given, B was given, C was given, our universal set was given, but A complement was not given. So before you go through the process of finding the intersection, we can't find the intersection of something if we don't know what's in that original thing. So we need to do a little bit of work off to the side and first figure out what would A complement be. Now we've done finding the complements of sets already. So as a quick review, I encourage you to pause the video and attempt finding A complement on your own, and then unpause to check your work. So to find A complement, I look first at everything in A, and I make a note above it in the universal set to tell myself, don't include this in the A complement. If 1 is an A, it can't belong to the complement. 2 is an A, so it can't belong to the complement, as is 3, as is 4. So everything that has not been marked will be an A complement. So my A complement is 5, 6, and 9. So I now know what is A complement. Now I also know what B is. I'm going to, instead of leaving it here, which is visually far apart, I think it will help me be more consistent in my work if I label B directly below. Here I'm just copying 2, 4, 6. So I clearly know what is in both sets, so I can begin to ask myself, what should belong to their intersection? Now you know this is intersection because the upside down U represents intersection. The definition of the intersection of set is everything that's in the first that is also in the second. So what elements are in common between these two? 5 is an A complement, but it's not in B, so it should not belong to the intersection. 6 is an A complement, but it's also in B, so it should belong to the intersection. 9 is an A complement, but it's not in B, so it's not in the intersection. 2 is in B, but it's not an A complement. 4 is in B, but it's not an A complement. 6, we've already clarified, should be in the intersection. So the intersection is the set which only has the element 6, because it is the only element that's common to both A complement and B. Okay, now let's turn our attention to the next example. Take a moment to think about how would you read this, left to right. This would be read as A intersect the set B union C complement. Now this has quite a bit going on. I have both an intersection and a union, and I'm also dealing with the complement of a set. So in doing these multi-step problems, we need to deal with first things first. And the first things will always be indicated by the parentheses. So before I consider A intersection this, I first must understand what is this. But in order to understand this, I have to know what is B, I have to know what is C complement, and then I have to understand what the union of those two things would be. So let's just go about this in an orderly way. Do we know what B is? Yes, B was one of our original given things, so I'm just going to copy that one out. No additional work needed. It was told to us. Okay, next, before I consider their union, I have to ask myself, do I know what C complement is? And the answer to that is not directly. I know what C is, so I can find C complement, but I need to do that work separately. So to find C complement, remember you look at everything from C and you exclude it from the original universal set. So I erase the marks that I made earlier, and I say 1 is in C, so I shouldn't include it in my C complement. 3 is in C, so I should not include it in my C complement, as is 6 and 9. So the remaining items should be 2, 4, and 5 are what remain to C complement. Now that I understand each set separately, and I've listed them out clearly, I can now consider what should their union be. So the union of sets is everything in the first set plus everything in the second set. So for unions, all I have to do is list out everything from the first set, 2, 4, 6, and then everything from the second, and if possible, I try not to write things that have already been included twice. So 2 was already included, so I don't rewrite it. 4 was already included, so I don't rewrite it. 5 is new, so I include that. And this is our B union C complement. So now that I understand what should be in B union C complement, I can now consider intersecting it with A. So I write down what is A. A was already given, so I don't need to find that. A is the set of 1, 2, 3, 4. And then in order to find their intersection, remember, what do you do for the operation intersection? You write down everything that they have in common. So I'm going to mark what items they share. So I look B union C, first element is 2. 2 is common to both B union C complement and A. 4 is also in B union C complement, and it's also in A. 6 is in the first, but it's not in the second. 5 is in this, but it's not in this. 1 is in A, but it's not here. 3 is in A, but it's not here. So the only items that they share in common are 2 and 4. And that's what belongs to the intersection. So as you do these problems that have multiple different sets, unions, intersections, and complements, remember that you have to work in an orderly way. Parentheses should always be understood first, and anytime there's a complement listed, you first have to write that out on paper. Once you have both the sets clearly understood, then you can find their unions or intersections. Next up, let's do these 2 examples, still with our basic same universal set and subsets A, B, C. First, read both of these and identify what's the difference in their notation. So read this one out loud, left to right, then read this one. I would phrase this first one as B complement, union, C complement. And I know anytime I'm asked to find a union or intersection, I have to understand both things separately before I can understand their union. So this begins by telling me I need to find B complement, I need to find C complement, and only when I have these listed out could I consider finding their union. And the union of sets is just everything in the first plus everything in the second. In comparison, this one, because of the parentheses, it's telling me to first find B union C. And once I know what's inside B union C as a new set, I need to take the complement of that, which means everything in the universal set that was not in B union C. So first up, I need to find B union C. And then once I know that, I'm going to go through the process that we've done multiple times before and find the complement. So if you feel confident with these 2 processes that we've learned so far, dealing with the unions and intersections of complements, I'd encourage you to pause the video now and attempt these 2 on your own. Unpause and you'll be able to check your work. So as we outlined in dealing with the first one, Before I can find the union, I have to understand the two things separately. B complement and C complement were not one of the provided subsets, so I must find them separately, and then once that's done, consider their union. Now, B complement is everything that's not in B that's in the universal set. So 2 was in B, so I exclude it from the universal. 4 was in B, so I exclude it, as was 6. So what remains for B complement is 1, 3, 5, and 9. Okay. I erase that, and then I repeat the process with the elements of C to find C complement. 1 was in C, so it's excluded from C complement. 3 was in C, it's excluded, as was 6 and 9. So the only elements remaining for C complement are 2, 4, and 5. Now as I consider the union of B complement and C complement, because I can clearly at a glance identify what are the elements of B complement and C complement, I can quickly write down their union. As to find a union, I just write down everything in the first set, followed by everything in the second set, excluding repetition. So I quickly write down 1, 3, 6, and 9 from the first set, and then I add in anything that has not already been written. So 2 hasn't been included, so I rewrite 2. 4 hasn't been included, so I write 4. 5. Oh, I noticed an error here. Y'all probably caught this as I was working. Here I wrote 6, but it should have been 5. I think I was just going forward in the pattern, so that should be replaced with 5. Now 5 was already included, so I said 2 was not included, so I rewrote it. 4 was not included, so I rewrote it. 5 was already included, so while I could write it again, I don't have to because it's already included here. So I now close the parentheses. That's the union of B complement and C complement. Next, we're looking at the complement of the set B union C. I know before I can take a complement, I need to understand the set itself though. So I need to figure out what is B union C. Now luckily I know B and I know C. Those were provided to me. So if it helps, I'm going to quickly write those down just so that they're visually in the same place, although it's not necessary. And then I know unions say everything in the first set plus everything in the second set, avoid repetition if possible. So 2, 4, 6. 1 hasn't been included, so I rewrite it. 3 hasn't, so I rewrite it. 6 has already been covered, so we don't have to repeat it. 9 hasn't been covered, so I rewrite it. So this is B union C. So then the complement of that would be I need to remove everything that belongs to B union C and say everything that's in the universal set but not in B union C. So I just go through the process. 2 is in B union C, so it shouldn't be in B union C's complement, excluding each element. So the only thing that's left to be in B union C complement is the element 5. And just a quick check of your work, did you include the braces for your sets? Remember, that indicates when the set begins and ends. So a few things to take away from these. For these problems, if you're ever asked to find something involving a complement, you should first do work off to the side to identify what would be that complement. If there are parentheses, you deal with the parentheses first. And all the work that we do off to the side helps us in determining the overall unions and intersections that we're asked to find. So we found the elements that belong to the unions, intersects, and complements of different sets. Now let's practice shading Venn diagrams that represent particular set operations. So we begin with the information that U is our universal set, A and B are subsets of U. Draw a Venn diagram and shade the regions that represented by here. So reading this left to right, I need to figure out what is A complement intersect B. And unless otherwise mentioned, or something that we can reason through the problem, if it's not clearly mentioned and you have sets A and B in your Venn diagram, Unless otherwise indicated, you should draw them with some overlap. Now, if the word problem makes it clear just by how it's described that there is no overlap, then of course you should draw them separate. But unless otherwise mentioned, we assume there's overlap and we include that in our drawing. So I'm going to label my universal set is the whole, everything enclosed by the rectangle. A can be this set, B can be this set. Now keep in mind, this is all of A, but I've just fragmented A into the parts of A that are also shared with B, and then the parts of A that are completely A's alone. Similarly, this is all of B. This is the part of B that's shared with A, and then this is the part of B that's B's alone. Now, if I was to shade A intersect B, a different problem, we've done this already. This is just the intersection. However, that's not what I'm asked to find. Instead, I'm asked to find A complement intersect B. So unless I really understand what the complement of A should look like, then I can't understand what its intersection with B should look like. So just as before when we wrote out the elements of A complement, in my Venn diagram, I'm going to make sure I understand A complement, so I'm going to draw a small Venn diagram off to the side to help me understand that. So here's my copy, A and B. Now A complement is everything in the universal set that at the same time is not a part of A. So it's like I'm excluding A but including everything else. So A complement then could be here. Everything, or maybe I'll start it easier to just start excluding A and then coloring everything that doesn't involve A. So that's A complement. Notice this part is not shaded because while it's a part of B, it's also a part of A. So that's why it's not shaded in the complement. Now we can probably visualize B a bit more easily, but just in case, if it helps, we quickly sketch B off to the side. So this is kind of our work off to the side. This will be what B is. B is everything in this circle. And now you think, now that I can clearly visualize both sets separately, I consider their intersection. Remember, intersection is the only thing they share in common. So the way I think about it in terms of shading Venn diagrams, if that section is shaded in both groups, it's shaded in the intersection. So this outside section is shaded in A complement. Notice it's not shaded here, so I do not shade it in the intersection. All of A is not shaded in A complement, so I can't shade any of A in the intersection, even though it's shaded here. Since it's not shaded here, it doesn't belong in the intersection. However, this portion of B is shaded in A complement, and it's also shaded in B, so since it's shaded in both, I should shade it in the overall intersection. And then just visually check, are there any other sections that are shaded in both diagrams that should be shaded in the overall? Remember, there's basically 1, 2, 3, 4 sections to look at. And the only section that is shaded in both is this, which we've already have shaded here. So this is in purple or pink, our A complement intersect B. Next, we're asked to shade what would be represented by A complement union B. Now we've already determined in our last example the work needed to figure out what is A complement, what is B complement, so let's just recopy that here. And we have our basic generic universal set A, B, and unless otherwise indicated, always leave room for some intersection. So now that we know what A complement looks like visually in a Venn diagram, we know what B looks like visually in a Venn diagram, we've understood each set separately. We now consider what would their union look like. Remember, the union has the idea of everything in the first plus everything in the second. So in terms of the Venn diagram, I always think if it's shaded in either, it's shaded in the final for unions. So I'm just going to start shading everything from the first and then shade everything from the second. So we have everything outside of A from the first is contributed. And then once we finish that, we add to it anything that was shaded in the second diagram that has not already been included from the first. So now we focus visually on this second diagram, and we ask ourselves, what was shaded here? Well, the only thing shaded here was all of B. So visually we look, have we shaded all of that here from the first? No, we still have this middle section to add to it. And then everything from the second will be layered onto the first. So I also add this section. So this is the Venn diagram that represents A complement union B. So as we think of these two examples, they involve the same two sets, A complement and B. However, they were joined with different set operations. The first one was the intersection. So when coloring Venn diagrams for intersections, you think, if I understand what's in the first one listed and I understand the second one, then the intersection is just what they have in common shaded. And then for unions, if I understand what's in the first and I understand what's in the second, then in the union is everything shaded from the first plus everything shaded from the second. And in both cases, taking a few minutes to draw the basic Venn diagrams for each individual set, I believe can really help you consistently get the correct answer for what should be the union and intersection of those sets, or even the complements. So be sure to take the time to draw these simpler sets off to the side. Now, if I have a Venn diagram, not only could I shade certain sections, but if I have particular elements listed in the universal set and the subsets A and B, I can say particularly where should those elements reside. Should they reside in A? Should they reside in B? Should they reside in the overlap of A and B? Should they be in the universal set but not in A or B? And the way we do that is we begin with our generic Venn diagram. Or I guess before we draw that, I should actually consider, this is my universal set. And in order to draw my Venn diagram, I want to know should my subsets have overlap. So just briefly, you look, are there any elements in common to both subsets? Okay. I think I see T is in A and B, as is V. Those are the only two things in common. But if there's even one thing in common, that's enough to know that I should draw my Venn diagram with the intersect of the two sets. So I'm going to make sure there's an intersection. I'm going to draw my diagram large enough that my writing won't be cramped. So this is my universal set, the whole rectangle, and everything inside it. This is A, this is B. And whenever we're asked to locate elements in the Venn diagram, I always encourage students to go from the most restricted sets outward. So if you think of this as one section, a second section, a third section, and then this part that's outside of A and B as the fourth section. The one with the most restrictions is this intersection, because in order to live here, you have to both be a part of A and a part of B. We already identified just by our initial consideration of how we should draw our Venn diagram that there are two things in common between A and B, T and V. So I can place T and V anywhere so long as they're in this intersection. As long as they're in the right section, the location of them doesn't matter. So I could have T and V, or I could have written it as V and T. They just have to be in the right section. And to make sure I don't recopy, I kind of am going to make a note everywhere there's a T or V listed, either in A, B, or the universal set, so I know that those have been dealt with. This is just a way to keep track of everything. The next most restrictive sets, after we've dealt with the intersection, is either the elements that are just A or either the elements that are just B. Let's just go alphabetically. Let's deal with the elements that are just A. I know the elements that are just A are R, S, and U because they're the ones that I already didn't include in my intersection. So R, S, and U. Again, where you place them does not matter so long as they're in this section that's just A. At the same moment, since I've already written them down, I'm going to exclude them from the universal. They've already been taken care of. Next, we're going to include the things that are just in B. You've already got the V and the T as part of the B that's shared with A, so the only thing that remains is X. I remind myself that I removed that from the universal. So I've written all the elements from A, all the elements from B, and then from that there's still some elements that are outside of A and B, namely Q, W, Y, and Z. And this last step is why I think it's very helpful to keep track of the things that you've already written down just by dots above as soon as you write them, because once I've dealt with everything in A and B, I nicely have indicated what element should live outside of A and B. So Q, W, Y, and Z can be anywhere so long as they're in this section that lives outside of A and B but within the universal set itself. So let's just list them. Maybe we have Q, W, Y, and Z. Again, their spatial orientation doesn't matter so long as they're in the right section. And this will be, you know, to do this type of problem when the prompt says place the elements in their proper locations or locate the elements in the Venn diagram based on the description of our universal set and subsets. And then work your way from the most restrictive outwards. So that's it for this section. Remember, you're always welcome if you have questions to contact me via email or Canvas message, and I would be happy to answer your questions.